In this video, we're going to learn how to represent truth and falsity in Python and how to work with logical connectives. There's a special type of variable in Python which represents truth or falsity, and that's called a Boolean variable. You can create Boolean variables by using the word true with a capital T or false with a capital F. In the first code cell here, I create two variables, P and Q, where P has the value true and Q has the value false. In Python, you can check the type of a variable using the type function. In this cell, I've called the type function on P, and you can see the output is bool. That's short for Boolean. That's the name that Python uses for the type of variable which can be true or false. It's important that you use the capital T in true and a capital F in false always, otherwise it won't work. Logical connectives like and, or, and not are built into Python. You use them just in the same way that we use logical connectives in ordinary propositional logic. So here is P and Q. Since P is true and Q is false, this should give us the output false, and it does. On the other hand, P or Q should be true, and not P, typed like this, will be false. The logical connective implies is not built into Python. So in the next code cell, we're going to define that. We define Boolean functions just in the same way we define any other function. On the first line, I have the word def to tell Python I'm starting a function definition, then the name of my function, which will be implies, and then the two inputs, which I'll call P and Q. On line 2, we specify the output of the function as not P or Q. You know from 0005 that not P or Q is logically equivalent to P implies Q, so this should give us the correct answer. Let's see if this works. In this code cell, I've printed out all of the possible inputs to implies to see what we get. You can see that true implies true is true, true implies false is false, false implies true, and false implies false are both true. So this really has recreated the correct truth table for implies. The reason I need print statements on the first 3 lines of that code cell is that when you execute a code cell, only the value produced by the last line will be displayed, unless you have print statements. We've just seen how to create Boolean values directly using the keywords true with a capital T or false with a capital F. There are other ways to create Booleans in Python. A very common way is to use comparisons. For example, if you have two numbers, A and B, you might ask, is A greater than B? And the statement that A is greater than B is either true or false. So we can use this in Python to produce a Boolean value. Let's look at how to use greater than and less than in Python. In this code cell, I have the statement 1 greater than 0. I hope you agree that's a truth statement, and when I executed it, it's going to produce a Boolean value, in fact the Boolean value true. Similarly, if I type 1 less than 0 like this will produce the Boolean value false. Python has various other comparisons built in. For example, it has less than or equal to and greater than or equal to. To represent less than or equal to, you use a less than and then an equal to equals sign. And to represent greater than or equal to, you use a greater than symbol and then an equals sign. In the next code cell, I define two variables A and B, where A is equal to 1 and B is equal to 2. On the last line, I ask, is A greater than or equal to B? You can see that's false. On the other hand, if I ask if A is greater than or equal to A, I get the answer true. So these comparisons give us another way of creating Boolean values. There are two more comparisons I want to talk about, which are equals and not equals. But we already have a use of the equals symbol, and you can see it here in this code cell. We use equals for assignment. That means we can't use a single equals sign to compare values, because the syntax would look exactly the same as when we assign a variable a value. For that reason, to compare whether two things are equal in Python, you must use two equal signs. This is really important. It's a very easy way to make mistakes. if you accidentally use 1 equal sign where you meant 2 equal sign, very bad things can happen. I'll show you an example of that in a second. Let's try double equals first of all. So in this code cell, we're going to test whether 1 is equal to 0. To do that, we have to use 2 equal signs. When I execute this, of course, I get the value false. Let's look what would happen if I tried to use a single equal sign. So if I forgot that I was supposed to use 2 equal signs to test for equality. First of all, I get an error here. So this is good. I'm told by Python that I made a mistake. The syntax error says can't assign to literal. What it means by that is I'm trying to use a single equal sign as if I was assigning a variable a value. But on the left-hand side of the equal sign, I don't have a variable name. I've got a number, and therefore it tries to do a variable assignment, and it fails because what was on the left of the equal sign was not a variable. Unfortunately, if you make the mistake of using 1 equal sign where you meant 2 equal signs, you won't always cause an error. You can, in fact, produce unexpected behavior. Previously, I defined 2 variables a and b. Let's imagine that what I meant to do was check whether a was equal to b. You can see they've disappeared off the top of the screen, so perhaps we've forgotten the values and we want to check whether they were equal. Well, now, if I forget to use 2 equal signs and I type a equals b, this is a big mistake, because what I've now done is I've reassigned the variable a to be equal to b. So I've in fact changed a where I meant to simply check whether it was equal to something else. You can see that this might cause all kinds of strange errors if you were writing a complicated program. So it's very, very important, if you want to test equality, you must remember to use 2 equal signs. So here's another example where we're going to test equality. Is 1 divided by 2 equal to 0.5? The answer is yes. In Python, 1 divided by 2 is 0.5. Our final comparison is not equal to. In order to check if 2 things are not equal, you use an exclamation mark and then a single equal sign. For example, 1 not equal to 2 will give the answer true. On the other hand, true not equal to true will be false, because true is equal to true. In general, you can test for equality and for 2 things not being equal for any kind of variable, but comparisons are only available for certain kinds.